Distance Learning with Lee, where I make learning mathematics super easy. On today's video, I'll be going through a possible geometric sequences question that you can use in preparation for your grade 12 mathematics tests and exams. So let's get to it, right? First question, given the sequence 3, 6, and 12, determine the 10th term of the sequence. All right, so the first thing we need to do is we need to first confirm that this is a geometric sequence, and we do that by seeing if we have a common ratio between the consecutive terms. Consecutive meaning terms that follow each other, right? So let's do that. So we have the first term of this sequence is 3. So that's your T1. Okay. And then so we've got our first term, which is your T1. We've got our second term, which is 6, and that's your T2. And we've got our third term, which is 12, and that is our T3, right? So what does a geometric sequence want us to, how does it want us to prove if we've got a common ratio between the consecutive terms? So the formula that we're supposed to use is T2, your common ratio, is equal to T2 over T1, right? Which is equal to T3 over T2, and that is equal to Tn over Tn minus 1. Okay, so let's do that. What is our T2? Our T2 is equal to 6. So we have 6 over, our T1 is equal to 3. Okay, and that should be equal to T3, which is 12, over your T2, which is 6. So guys, let's calculate. 6 divided by 3 is equal to 2, and 12 divided by 6 is still equal to 2, right? Therefore, this is in fact a geometric sequence because we have a common ratio between our consecutive terms. Okay, we've got a common ratio. So now the question is asking us to determine the 10th term of the sequence, right? So to determine the 10th term of the sequence, we first need to get the formula for the nth term. Okay, we first need to get the formula for the nth term. Okay, so let's do that. We know that when you're working with a geometric sequence, the general formula for a geometric sequence is A times R to the power of n minus 1. Okay, so now to get the formula of the nth term, right, of this particular sequence, we need to basically substitute the value for A. And what is our A? Our A is equal to our first term. Okay, so I'll just write it there. A is the first term, and your R is your common ratio. Okay guys, so let's do that. So for our sequence, right, for this sequence, what was our value for A? What was our first term? Our first term is 3, so we're going to substitute that, right? So we're going to have Tn is equal to 3, which is our first term, multiplied with, what did we get as our common ratio? Our common ratio R is equal to 2. We're going to substitute our 2. And then that is going to be raised to n minus 1. Okay, so now we have obtained our formula for the nth term. Okay, so this is the formula for the nth term. Okay, and once we have the formula for the nth term, we can determine the 10th term of the sequence by just substituting 10 where you see n, because we are trying to determine the 10th term of the sequence. So we're trying to get how much the term that is in the 10th, what's the value of the term that is in the 10th position in our sequence, right? So that is what we're trying to do. We are just simply going to substitute 10. Okay, we're going to substitute t. Where you see an n is the 10, right? Which is equal to 3 times 2, all raised to the power, that's n. So we're going to have 10 minus 1. And that is going to be equal to 1,536. Okay, guys. Then we're done. Okay, so just a quick recap for this question. We are given a sequence, right? 3, 6, and 12. We know that it's a geometric sequence because we are under the heading geometric sequences. Okay, but we still need to confirm that it is in fact a geometric sequence. What do we know about geometric sequences? We know that geometric sequences have a common ratio between consecutive terms. Consecutive terms means terms that follow each other, right? So we know that there's a common ratio between them. And how do we calculate the common ratio? Common ratio is calculated by taking your second term divided by your first term, which should be equal to your third term divided by your second term, and that should be equal to your Tn divided by Tn minus 1. It goes on like that, right? And before we can determine the 10th term of our sequence, we need to first find, right, the formula for the nth term, and we do that by saying we know the general formula is Tn is equal to A times R to the power of n minus 1. We substituted the value of A, which is your first term, and that is 3. We substituted our common ratio R, which we found to be 2, and then from there we had the formula for the nth term. And once we have the formula for the nth term, we could determine the 10th term of the sequence, and we found that the 10th term of the sequence is equal to 1,536, right? 10th term meaning that 10th term of the sequence means that we want the value of the term that is in the 10th position. We want the value of it, and we found that the value of that term that is in the 10th position is 1,536. Okay, guys, let's move on to the next question. If you're given, right, a sequence like this, so it's 2, 4, and 8, right, and they want you to determine the number of terms in this sequence. First thing we need to ask ourselves is that, what is this question asking us? It wants us to determine the number of terms in the sequence. How do we determine the number of terms in the sequence, right? So we need to, oh, sorry guys, I actually forgot to put something here. Okay, so we are given a sequence 2, 4, 8, right? And the sequence ends at 1,024. right? The sequence ends at 1024, right? So now, since we know that this is where the sequence ends, the question asks us to determine the number of terms in this sequence, right? How many terms are there in this sequence? So we need to determine that. And before we can determine that, okay, we first need to confirm if this is a geometric sequence. So let's do that. Let's confirm that we are in fact working with a geometric sequence. And when you're working with a geometric sequence, we know that we have a common ratio where your T2 is equal to T1, and that is equal to T3, which is equal to T2, and that is equal to Tn over Tn minus 1. Okay, and then, okay, this is my first term, this is my second term, and 8 is my third term. Okay, so that's that. We're calculating the common ratio. Therefore, R is equals to, so what is my T2? It is 4. What is my T1? It is 2. That should be equal to T3, which is 8, over my T2, which is 4, right? So let's confirm. 4 divided by 2 is 2. 8 divided by 4 is still 2. Therefore, we do have a common ratio, okay, between our consecutive terms, and our common ratio is 2, right? And therefore, we can confirm that this is a geometric sequence. So we can start with our question. Okay. The question is asking us to determine the number of terms in the sequence. So before we can even determine the number of terms, right? Before we can even determine the number of terms, we need to start off with the general equation of a geometric sequence, which is A times R to the power of n minus 1. Okay, because now we found that our common ratio is equal to 2, we're going to substitute that into our equation. And because we also know that our A is equal to your first term, okay, we're also going to substitute that into our equation, right? And therefore, the general term for the general formula for the nth term is equal to A, and your A is equal to 2, your R is equal to 2, n minus 1. Okay, so that is our formula for the nth term. Okay, for the nth term. And now we want to determine the number of sequences in the number of terms in this sequence. Okay, so we know that our sequence ends at 1024, right? So that is the value of our last term. So that value is going to be substituted on our Tn. Okay, and we want the position of this value. Okay, so what's the position of this value in the sequence? What's the position of 1024 in this sequence? So that's what we're trying to get, right? So we're going to substitute that into our formula. So I'm just going to put that as C so that you can see how I am basically cutting these, how I'm segmenting this question. So you're going to have, right, the general formula, which is Tn, which is equal to 2 times 2 to the power n minus 1. We know that, okay, we're given a value of 1024, and we're trying to find the position of this 1024 in our sequence, right? So we're trying to solve for n. Okay, so how do we solve for n? So the first method I'm going to show you where you can solve for n is using log laws. And then the second one, how I'm going to solve for n, is using the exponential laws. Okay, so using our log laws, so the first one, I'm just going to take you through log laws. When you're using log to solve, okay, if you're using log laws, okay, to solve, this is how we're going to do it. Okay, first thing you need to do is we're trying to get this 2 to the power of n minus 1 on its own. So what can we do? We can just simply divide by 2 on both sides, right? And if you divide by 2, what do you get? 1024 divided by 2, 24 divided by 2 is equal to 512. Okay, so it's 512, and that is equal to 2, right, to the power n minus 1. Okay, so applying log laws, I'm just going to make a small note here. If you're given a b to the power of a, and that is equal to c, and you have to solve this type of an equation using log laws, what you're going to do is you are going to bring this a down. Okay, you're going to bring the a down, and you're going to have a, right? And then on your right hand side, you've got a c. Right, so we're gonna maintain that c. It has to still, I'll put it in this way, it has to remain big. Okay, the c has to remain big. So for it to remain big, that means that this b has to be small when it moves from the left hand side to the right hand side, right? So I'll say log, and because the b needs to be small, it needs to be, is it called a subscript? Okay, log b of c. Okay, so because this c still needs to be big because it was big on the right hand side, so you leave it as it should stay like that, as a big c. And then because this b moves from the left hand side to the right hand side, it needs to be small, right? So it goes there, right? So it must be like a subscript. Okay, so that is how we're going to solve for this. Okay, so looking at this question, we're trying to solve for the n, you're trying to solve for n, right? We're trying to solve for n. So we need to basically, using our log laws, right, this n minus 1 needs to come down. Okay, so it's going to be n minus 1, and that is going to be equal to the 512 needs to remain big. So we already know that we're going to have log of, right, the 112, because it needs to stay big because, you know, it's already big on the left hand side. And then because you're moving this 2 from the right hand side to the left hand side, okay, it has to be small on this side. Okay, guys, this is really the simplest way that I think I can explain it to you guys. But please comment on the comment section if you have another way that maybe you think another person might understand it in terms of the log. Okay, guys, so the log base 2 of 512 is equal to what? Okay, you simply just punch into your calculator. Log base 2 of 512 is equal to 9, right? And then, so that's equal to 9, and that is equal to n minus 1, right? And you simply just solve for n. Okay, n plus 1, therefore n is equal to 10, right? So therefore this sequence has, okay, the sequence has 10 terms. Okay, so the sequence has 10 terms. So meaning that this 124 the value of 1,024, the value of 1,024 is the 10th term in the sequence. Okay guys, and then I'm just going to also explain how you can solve this using your exponential laws, because this is just if you use a log law. So I'm just going to move on to this side and just explain it for people that want to use probably an exponential laws to solve this problem. So if you have 1,024, and that is equal to 2 to the power of n minus 1. What do you do? Okay, so first thing you do here, obviously you're still going to divide by 2. So you're going to divide by 2 here, divide by 2 there. 1,024 divided by 2 is 512, and that is equal to 2 to the power of n minus 1, right? And then if we are working with if you're working with exponential laws, right, what you need to do is we're trying to have the bases to be the same so that you can just simply be left with the exponents and solve, right? So how can we make the base the same? Okay, so if I take 2 to the power of 9, right, I'm trying to make the bases the same, right? These are the bases. So I'm trying to make them the same. So to make this base the same as that base, right, I need to say 2 to the power of 9. What is 2 to the power of 9, guys? You can check that for me. 2 to the power of 9 is equal to 512. Okay, so already we have the bases the same. And 2 to the power of n minus 1, right? And with exponential laws, if the bases are the same, you can simply just drop the exponents and you're going to have 9, which is equal to n minus 1, okay? And then obviously if you move your 1 to the left hand side, you're going to have 9 plus 1, which is equal to n, and that is 10, which is equal to n, okay? And this is an alternative method that you can use when you want, if you want to use your exponential laws instead of log laws. Okay, guys, I'm just going to do a quick recap for this question, right? So in this question, we were given a sequence. Okay, it's a geometric sequence, and okay, let's just solve this. Okay, we're given a geometric sequence 2, 4, 8, and the last term of our geometric sequence is 1,024. The question asks us to determine the number of terms in this sequence. Okay, before we can even start with our questions, I always need you to confirm that it is a geometric sequence. And I mean, in the exam, if you're told that it's a geometric sequence, you don't have to confirm it, but I mean, you still need to calculate the common ratio. Okay, so basically with us as well here, we just calculating the common ratio, and by calculating the common ratio, we are confirming that it is a geometric sequence, and we calculated our common ratio to be equal to 2. We used the general formula of a geometric sequence, which is Tn is equal to A times R to the power of n minus 1. We substituted your A, and your A is equal to the first term, which is your 2. We substituted our common ratio, which is R, which is equal to 2, and then it's n minus 1. And by doing that, we got the formula for the nth term, right? And once we have the formula for the nth term, we could determine the number of terms in this sequence. We already know that the value of the last number in the sequence is 1,024. So we just put that value down and you substitute it into your Tn. And then you solve for n to get the position of that number on the term. And we used log laws or your exponential laws to solve this equation, right? So we've got 1024, which is equal to 2 times 2 to the power of n minus 1. Using your log laws, what we did is that because we had to first divide by 2, you divided by 2, and you had 512, which is equal to 2 to the power of n minus 1. You simply bring the n down, right? And because the 512 is already big on the left hand side, it stays big, right? Therefore the base is going to be 2, so you've got log base 2 of 512, which is equal to n minus 1, and therefore your n was equal to 10, right? Meaning that this sequence has 10 terms, meaning that the 1024 is the 10th term in our sequence. Using exponential laws, what you always need to remember is that the bases must be the same for you to just work with only the exponents. And then we try to get the bases to be the same. 512 is the same as saying 2 to the power of 9. And therefore here we could see that now our bases are the same. We brought down the exponents. 9 is equal to n minus 1, and 9 plus 1 is equal to n, and we still got our 10, your n to be equal to 10. If you want to see more mathematics tutorial videos to have you ready and prepared for your tests and exams, and if you want to watch videos where I go through your mathematics past papers, please don't forget to subscribe, and see you on my next upload. Thank you guys, and goodbye.